Alright, let's talk about special right triangles. And the first special right triangle would be if we have a 45, 45, 90 degree triangle. And what this says is we have our two side lengths, which are going to be the same because the angles are the same. And then the hypotenuse is going to be the side length times the square root of 2. And you kind of saw that when we did that last one with the square. All of those worked out as the side length times the square root of 2. So let's try this. So let's say I have a triangle that's 45, 90, 45, and I have a side length of 4. So that means, based on that theorem, that this side length is going to be 4 and this side length is going to be 4 square roots of 2. So let's just test that and make sure. So if we put that in the formula, we'd have C equals the square root of 4 squared plus 4 squared. So C would equal square root of 16 plus 16. So C would equal, oops, that's not a C. C would equal the square root of 32. You factor out 32 to be 2 times 16, and 16 is 4 times 4. So I can take that 4 out, so that would be 4 square roots of 2. Alright, the next special triangle is the 30, 60, 90 triangle. And what that tells us is the shortest side here is going to be S. Our hypotenuse is going to be S square root of 3. And our longest side, oh wait, sorry, I did that backwards. Our longer leg there would be S square root of 3. And our hypotenuse would be 2S. So we can put some numbers into this. Test it out. So we have a 30, 60, 90 triangle. And let's say our side length is 5. No, let's use a different number. Let's say 4 again. So that means our hypotenuse is 4 times 2, which equals 8. And our longest leg would be 4 square roots of 3. So we can put this into the formula and test it out. So if I wanted to prove that this is 4 square roots of 3, I would do B equals the square root of C squared minus A squared. So put the numbers in there. So we'd have the square root of 8 squared minus 4 squared. 8 squared is 64. 4 squared is 16. So B equals the square root of 64 minus 16. So B would equal the square root of 64 minus 16 would be 48. If you factor out 48, that would be 4 times 12, and 12 is 4 times 3. So I got a pair of 4's there, so I can take that out. So B would equal 4 square roots of 3. So I just proved that theory works. Alright, so let's apply what we just learned. So I got an equilateral triangle there, and I'm going to give you the altitude of 10. So because this is an equilateral triangle to start with, I know all the angles are 60. And when I put the altitude in there, I create a 90. And when I draw in that altitude, I take that 60 at the top and I divide it into two 30s. So I now have a 30, 60, 90 triangle. So if you remember what we just did, when we're doing a 30, 60, 90, we have S, 2S, and S square root of 3. So our longest side there is s square root of 3. So s square root of 3 equals 10. So to get our side lengths, we divide by the square root of 3. So s equals the square root of 3, or 10 divided by the square root of 3. Alright, so I know my side length down here is s, or I don't need to put the s, it's just 10 square roots of 3. Or 10 divided by the square root of 3. I keep saying it wrong. So if we multiply that by 2, we would get the hypotenuse. So if we do 2 times 10 divided by the square root of 3, we'd get 20 square roots of 3. Now we don't want square root of 3 in the bottom, so I'm going to multiply this whole thing by the square root of 3. And you'll see why in a minute. So 20 times the square root of 3 would be 20 square roots of 3. And square root of 3 times square root of 3 would just be 3. And so that's what this side length is. 20 square root of 3 over 3. So one last step here. I'm going to go ahead and find the perimeter of that triangle. So I know one of those sides is 20 square roots of 3 divided by 3. And there's 3 of those sides. So if I take that and I want to find the perimeter, would be 3, because I got 3 sides on my triangle, times 20 square root of 3 over 3. Well, 3 would cancel there. So my perimeter would equal 20 square root of 3.